One of the specializations of the Electrical Engineering's master program is Dependable Integrated Systems. A dependable system is a system that has been designed to satisfy the changing requirements of its users. During this specialization, you learn to combine hardware and software and to create an embedded system that is reliable and able to adapt to changing circumstances. Topics you could think about are the braking system of your car or smart usage of the energy grid.
So the great challenges that we work on right now is most now the congested grid. So that is something that we've seen in the last 1 or 2 years coming up also in the news. We just embarked on our energy transition with all the climate goals in place, all the concerns that people have. But we are dealing with a grid that is already quite old. So the big challenge is how can we really rapidly make sure that we use the existing infrastructure, but also make sure that the energy transition is not coming to a standstill. And for this, these embedded systems and the algorithms that we develop and that we research within our research group are the cornerstone to make sure that our society can keep on going with this energy transition. If we do not work together, we can easily cause blackouts in the grid. And I once did that in my research in a neighborhood where we had 20 electric vehicles that were charging simultaneously and we were baking pizzas. And already with that, 25% of the households then had an electric vehicle in the neighborhood. And this was for real. We had already caused a local blackout that I could really see and finally feel how maybe weak our electricity grid actually is. So I'm afraid that if we do not change our behavior and if we do not more consciously think about how we use our electricity and make sure that we use it when it's available, like when there's a lot of solar energy or a lot of wind energy, we will face a lot of challenges as a society.
The Dependable Integrated Systems specialization covers aspects from both electrical engineering and computer science. The program consists of 5 compulsory courses: System on a Chip Design, Embedded Computer Architectures, 2 courses on ethical aspects, and in discussion with your program mentor, you will choose either real-time systems or dependable computing systems as the 5th course you must follow. Next to the 25 EC of compulsory courses, you can fill 35 EC with elective courses. You can find a full list of electives on the website linked in the description. In this specialization, electrical engineering students work together with computer science students and embedded systems students to create reliable, integrated systems. The Dependable Integrated Systems specialization is offered by the Computer Architectures for Embedded Systems Group, or shortly, the CARS Group. In recent years, energy efficiency was the main research focus of the CARS Group. This direction started before 2005 with energy-efficient processing and communication subsystems for battery-powered embedded systems, such as mobile phones and wireless sensor networks. And right now, our energy group is working hard on implementing smart charging.
Yes, indeed. So this location is our SlimPark Living Lab, and that is really one of our living labs on the campus itself, where we bring our algorithms, our embedded systems, into reality and make sure that we can actually test in reality our algorithms with actual users. Because nowadays it's not only a technical solution anymore, but we need to make sure that also the users, you and me, are really able to work together with the system. Every time we need to make sure that we produce as much energy as we consume. From the old system where energy would come out of the socket anytime we needed it, we now go into a system that is fed by renewable energy, for which maybe sometimes we have a cloudy day or we have less wind, and we still need to make sure that there is a balance. And this balancing becomes harder and harder as we go forward in this energy transition. So we develop with students an app, and then you basically put in how much electricity you want and when you depart. And this is crucial information for an energy management system, because then if we know from all the users when they want to depart with their electric vehicle, we can basically use that information to make sure that we give everybody enough energy in time while maximizing the amount of solar energy that we locally use within this small grid over here. We have here charging stations, 9 in total. And over there we also have a battery. What we have is an Ethernet cable coming in with data from our energy management system. And then, as an important aspect, this embedded grid shield module.
So the idea is that we coordinate between the solar panels that we have in the vehicles, but that system might fail for whatever reason. And this grid shield module is really a backup to the other energy management systems that we have. And if it measures that there is an overload at the transformer over there, so it measures that too much electricity is being drawn from the grid, it will automatically kick in and start reducing the charging power of all the vehicles connected to it.
So the tests that we conduct here is, first of all, making sure that we have our algorithms. These are smart algorithms that even by AI driven make sure that they coordinate the energy with each other. So we test here how different devices can coordinate the energy and to make sure that the stability is there. But other things that we can do is, for example, suddenly plug out an electric vehicle or bring one of the systems down and then make sure and test whether the algorithms that we devised actually can take over and can detect these problems and figure out a new solution without causing a blackout, which means that all these electric vehicles would stop charging.
But for this to work, you need a good embedded computer architecture, which is one of the compulsory courses taught by Nikos Alachiotis.
My name is Nikos Alachiotis, and I'm an assistant professor in the Computer Architectures for Embedded Systems group. So in the course Embedded Computer Architectures 1, we are focusing on 2 parts. And in the first part, we are focusing on microcontrollers, and we are focusing on how input and output is handled, like collecting real input through a camera, for instance, or through a sensor, and getting the data out of it. And then in the second part, we are using FPGAs for efficient processing of this data. An FPGA is a field programmable gate array, and this is basically a hardware technology that can be reprogrammed after manufacturing.
So examples of embedded systems are, for example, FPGA chips. So these are programmable chips that you can really make your own architecture on, but also quite expensive. Other very interesting cheap solutions are, for example, the ESP32 chips. Already this cheap system can, with our algorithms, control more than 100 electric vehicles in a split second. And thereby they are still very energy efficient, so they can run off a battery, which also means that the energy they reroute in our electricity grid by keeping energy local reduces our grid losses. And those grid losses that we save are basically more than the energy it takes to run those systems. And if we want to transition to a sustainable future, we need to be efficient. And that is really where these embedded computer architectures come in. So what we do in our research, we really are looking into how do we actually create these new processors that are custom-made for the task that I need to execute. And by really zooming into what I need to do, tailor-made the hardware, so how the chip operates, but also the algorithms for that. By blending in those two together with the application that I need to do, we can make sure that these systems are cheaper and also more energy efficient, and that is what we need.
The content of the Dependable Integrated Systems specialization now goes beyond smart grids. It has been extended to also cover reliability of systems as an important aspect and streaming applications in the high-performance, high-tech domain. For example, phased array antenna systems, medical image processing, and signal processing on board of satellites. Learn more about this electrical engineering specialization by clicking the link in the description, or watch our YouTube playlist to learn about which other electrical engineering specializations we offer.